Let me introduce Prateep Misra. Prateep Misra is the Head of Technology and Engineering and Chief Architect at TCS, and he's been focusing on the TCS IoT Platform. He has a rich experience of 26 years running various Center of Excellence. His talk will be focused on the data-centric view of IoT and Industrial IoT. So let's welcome Prateep. No, yeah, I will start the timer.
So first of all, let me start with thanks for inviting me, and the other is this has been a humbling experience. Getting to know such greats of internet. Whatever I say or whatever I have been doing, essentially. We have been, standing on the shoulders of giants, and I did see some of giants yesterday. We have always assumed that the network is good and it works, but we all understand what has gone into make it so good and work. Thank you, Nalini, thank you, Adrian, Fred, and others who have made this happen. So I will be talking. It's a point of view, and my focus is what yesterday Nalini was referring to as a brick and mortar company. So we do software and services. Actually, our company is into things like application development and maintenance, and we do technology consulting, architecture consulting. We provide services. The focus is essentially on the so-called brick and mortar companies. And when I say IoT, I'll actually be, restricting myself to industrial IoT only, right? Although there are lots of interesting IoT use cases, and we have all heard of smart refrigerators and toasters and like that, but our interest is more on things that companies are using today, are spending their money on. And this has been based on the experiences I've been having with various projects that we are involved in, various customer engagements and meetings. And so this is a point of view, and the point of view is around data, and of course we all know that network is important. I won't be covering any network aspects of IoT or even devices. As they say, it's like the proverbial elephant, we all touch different parts of it. So today, just think I'm touching that data part of that elephant, and I'll be restricting myself to that. So it's like this, that in about 2011 there was an essay by a famous person in the networking world and now a venture capitalist, Mark Andreessen, who heads one of the major VCs in the valley. He wrote an essay that software is eating the world, and what he really meant was that all companies are becoming software companies. The innovations and disruptions are happening through software. And then he takes the example of things like Amazon, which at that time wasn't so world dominating as it is today. At that time it had probably just merely disrupted the border bookshop, and but again then he talks of Netflixes, but it's even more relevant now. We all know that all technologies are software companies, and even the most traditional brick and mortar companies, at least in my experience, probably Nalini would agree with, they are deeply focusing on their, software skills. They're all setting up their digital arms, and they are significantly investing their mind share in that. So it is still very, very true. This essay is more true than what it was in 2011, and therefore we can extend it that that software is also eating the IoT world. So the innovations that are going to happen, especially in all IoT for that matter, the disruptions and the innovations are coming through software. All the, of course, there's a device aspect of it, there's a networking aspect of it, and a lot of brilliant things are happening here. But a lot of the value add is actually coming even in the network stack. I know some of my friends who are in the business of, radio chips. They are saying that their algorithms are actually moving into software implementations. Earlier they would do the same thing in hardware, and probably, ASICs they would make, but now they are doing it on processors. They are doing things on software. So it is really a claim that software will eat the IoT world, and data is at the center of that. So that is the whole point of this talk today, is the emphasis on data, and that we really need to focus on data. It is a huge opportunity, and what I really intend is in this talk is to influence students and younger people in startups to really focus on data, and that's where if you want to rob the bank, if you want money, you need to rob the banks. So you rob data. That's where the money is. That's where the opportunities are. That's what I'm saying and claiming here, and I think some of you will agree with me on this. So again, we need to focus on data and data engineering, and that's because this is what the real world needs today, and in my view, it is what they're going to need it today. And we see the need for building skills around data and data engineering in all the companies who want to bring in IoT in their business, right? In the way they do business, in the way they are doing things now. So that focus on data is important, and people and companies with data skills will prosper, will do well, will make an impact. So that's something which we also have been thinking, and I'm trying to get that thinking within my own group. By the way, I am the architect of just one platform in TCS. It's an Internet of Things, cloud-based Internet of Things platform. This is what I've been working for the last 10 years or so, and this is what we are trying to bring in. All this data-oriented capability within our offerings and within our solutions. And I want to share some of those aspects of data orientation in industrial IoT in this talk. So I think it's always interesting to start or keep anchored around a use case, because it helps us to relate to things that I talk about later. So one example of an industrial IoT, and this is about the oil and gas industry, and this is an extremely asset-heavy industry. They do have lots and lots of assets, and So in one scenario is that these companies have offshore drilling platforms, and these are heavy investments. I mean, it really takes, but they also pay out for the next 20-30 years. These assets are going to be out there, and you can imagine a large offshore drilling platform has got over 100,000 large assets, and these are big investments. But they are also going to pay out. A large offshore platform can generate more than $50 billion of oil over its lifetime. And what these companies they're doing is, how do they maximize the utilization of each asset? So per barrel of oil, what's my investment in assets, and how long can I prolong the use of these assets? And as you can well imagine, the costs of equipment downtime, you can imagine how much it is on the business lost, and not to speak of safety events and other things which could really mess up things. So this industry is interested in knowing about data, about what's happening on the field. Also, they are all companies that have grown over the last 20-30 years. So they have a huge legacy of equipment, of different technologies, and each of these oil platforms are very sophisticated. I mean, they have their own what we call as level 1 automation systems. They have their own SCADA systems. They have their own PLCs and stuff like that. They are collecting data, and the sad part is that when someone wants to debug something, either a production problem or a maintenance problem, it's incredibly hard to debug what's happening. I think I can see Nalini is smiling, she understands. Yeah, in a way the IT plant is similar, But this is also wickedly difficult. And the problem is when you want to debug something, you get only a very siloed view of what's happening out there, And for example, if you want to know what are the problems in similar equipment in the similar area in these type of shifts, and you don't have data. You want to know who all have maintained this equipment in the past, and you don't have that data. If you have, so all these companies, they have what they call as data historians, but it's not in a common place. So suppose you want to compare the performance of a particular equipment by a given vendor, you have no way to collate and pull all the data from a given vendor's asset, right? So these companies, they are interested in what we call as contextual data. They want to collect time series data, they want to collect asset data, and you want to bring the context together, and we'll dwell more on and that kind of thing. The idea being, of course, is to get a view of what is happening and also keep things in sync. So remember, each of these offshore platforms actually have their own IT departments, their own administrators, and they are making changes in definitions. They are doing all kinds of things, and there is no global view of what is there. So what's there on the ground is probably not what it should be there in the systems, and there's no way of knowing it. So one of the key requirements is synchronization of all these events that are happening in terms of changing the structural information of these assets and bringing them together in a common place, but keeping everything synchronized and keeping all the linkages, whether it's to the time series data or other information. So we just keep this in mind when we talk of the real aspects of the data orientation. So going forward, very quickly, again, there is an architecture, reference architecture proposed by the Industrial Internet Consortium. This is one of the large organization which is trying to bring together some kind of guidelines in the area of industrial IoT, and in their reference architecture they have divided the entire IoT domain into 3 tiers: the edge tier with all the devices and actuators and controllers, and the proximity networks, all the industrial networks, etc. in that tier. And then you have the middleware layer, the platform tier, which is doing the bulk of the heavy lifting in terms of data ingestion, in terms of storage, in terms of stream processing, real-time processing, and providing an APIs and providing interface to all this data all the way down to the edge tier. And then of course we are all interested, finally the end user is of course transparent to all the magic that is happening, and you need to give them applications and dashboards, and more interestingly, people are now interested in digital twins, where essentially a model which is kept in sync with what is happening in the field, and then using the model outputs to control and actuate. And the other is digital threads. This is also becoming extremely interesting in all the companies that I am talking to. It is essentially about breaking silos of data. So they have their manufacturing execution systems, they have their PLM systems, they have their ERP systems, and they have the newer sensors that they are bringing in to augment their existing IoTs. But all of these are siloed, and there's no way for you to navigate from one to the other. So the digital threads is something, again, people are interested in. So this is what is the scope of industrial IoT. And the reason why we need data orientation is of course simplification. So there are certain abstractions that we want to bring in, and that is because it simplifies the business of creating IoT or industrial IoT applications and managing them. So I'll be talking a bit about these abstractions. Again, the value, as I said, I'll keep is in the integration. It comes from integrating the data across the tiers, across different systems. So this is what, and data orientation helps us in integrating. And of course, we all understand that this entire, everything is in the intelligence, and intelligence these days means using machine learning, and machine learning is based on data, and of course therefore data is really important for all IoT. And of course, I would also say that scaling becomes easy. Scaling of IoT applications, scaling of and of course at all times we are forced to make trade-offs between performance, between cost, between scalability, and again having a data-oriented view of IoT helps us in that. So these are, I'll take 3 examples of data abstractions. So one abstraction is the entire edge tier, if you will. Think of it as a virtual database, right? Although this kind of abstractions has not made its way into commercial products, but it's been an active field of research where people have the entire sensor network is thought as a database. Each node is a database. Think of it as a distributed database. And when you do that, you can use the common query languages to actually interact with the sensor network. So people have come out with just the way programmers use SQL kind of database. Think of yourself using a SQL kind of interface to interface with the sensor world, with the IoT world, right? So lots of research projects has gone into it, and then you use the constructs in the SQL world, like selections, which is filtering essentially, and joins, which is essentially correlations. So all the kind of edge processing that we do in IoT, you do it through the abstraction of a database and a query language on that database, right? So this also provides a lot of advantages, and I'll come to those. But of course, it's a top-down view of the whole thing. So typically, we tend to take a very bottom-up approach. We build networks, topologies, interested in them, and network endpoints. So again, in all these things, the network itself takes a back seat for the application developer. The application developer as actually using the database as an abstraction for developing the application. The second abstraction is again it's a more modern one, and it is already being used quite a bit in the world of IoT, where again everything is abstracted as a URL, right? So whatever you do on the sensor world is what you would do in a web resource, right? So every resource has a URL, and the standard operators that we use in the web world, which is like get operations and put operations and delete and post operations, whatever we do, so think of every sensor, every actuator and elements of that as a web resource, and you use the web paradigm, the RESTful paradigm to make, and a lot of magic is happening underneath. By the way, IETF has hugely contributed to making this work, right? There are IETF RFCs on something called the Constrained Application Protocol, CoAP, right? I think my colleague Abhijan has contributed in that RFC as well. So to make this magic work, there's a lot of great stuff that has happened in the IETF world. But this is again a very neat abstraction where we use a RESTful way of operating and think of everything in the device world as a tree of resources. So you have a node, and then you navigate down to the node, and then you have a node that interests you, and then you use the RESTful pattern, verbs like post or get to operate on that. Right? The third abstraction, again, very common, and again it's being used significantly, is of course the entire data distribution and message queue. I think this is something heavily in use, but again, this is something remarkable because it provides all those benefits where network itself is abstracted behind data, right? And the addressing is done based on data or data topics, and the clients are either data writers or data readers, right? And this is that public subscribe pattern. And on one hand, you have things like the messaging, the AMQP protocol, where still you have to worry about things like brokers and clients and etc. But something even more advanced in the abstraction scale is the data distribution service, which is a standard from the object management group, OMG. And again, heavily being used as part of the ROS, the ROS2 operating system for robotics. All our modern robots and UAVs and stuff, they are heavily using ROS. And ROS uses DDS as the abstraction, right? So here, of course, instead of knowing about network endpoints, we need to know about the data that we are interested in, and then we either read that data or write that data and update. But of course, we need to build in all the quality of service and the guarantees and all of that you need to build real-time systems, reliable real-time systems. All of these have been baked into under that abstraction itself. So again, keeping these abstractions in mind as an example, of course there will be more abstractions. And I think all engineers, I think all of us are really working on abstraction at some point or other. So it's not nothing new. Power abstraction is known. But of course, as we all know, abstractions help us in insulating the changes that's really happening. And then once you have these things abstracted, work done by other people, whether it is the work done by the microservices people in terms of load balancing and scaling, all that becomes available to you. And of course, security. Now you can actually, when you have abstracted your IoT as a set of data elements, you can use all these policy-based access to all those. You can create role-based access controls and all of that. That becomes easy. You can say, I will provide these kind of accesses to this class of users. But instead of doing it at the network level or the host level, you're doing all of those policy definitions at the data level, right? And of course, it simplifies development. Now, I can have anyone who understands the use of the RESTful way of programming to become developers of IoT applications. I don't need really brilliant people to do IoT-based application development. All of that has been neatly abstracted out, and therefore a large community of developers can come in and start contributing to it. The other very important thing, which I think for me is, I really like that. It's a wonderful thing, as I said. I think discovery is a wonderful thing. We really need to build flexible systems. We don't want hard coding. Right? How do you avoid hard coding in your applications, right? So one of the things that helps you avoid hard coding is discovery. Suppose everything kind of late binded, when something happens, my application will be able to accept those changes, right? And an important capability for that is discovery, right? And so for example, I know that a node exists or a data endpoint exists, and I ask, what are you capable of? What can you do for me? And then that node, tells you back, I have these things with me. You can do all of these things with me, and this is what it is. And they can also point you to other ontologies or catalogs, right? In England, a group of researchers did a very interesting work called HyperCat, which is called hyperlinked catalogs, which was primarily meant for smart city applications. So it really lets you build systems incrementally. By the way, most industrial IoT systems are system of systems. I mean, they really emerge, things, they get built over a period of time. And you really want that flexibility. And many of these are infrastructural things. You don't go and change them, right? I mean, you don't want to touch many of these things for years, right? So how do you build applications that make use of things that were done in the past and that will come out? So you really need this discovery and the ontology linkages. So I need to know what is out there, and I need to know what it means, and I want to have everyone evolve on their own independently, and yet I want to build systems that are actually systems of systems. So in that case, this discovery capability is very important, and that is all enabled by the data abstraction. So again, a very important use case for data orientation is simplification. Simply designing, architecting application development, administration becomes easy when we have these kind of abstractions, and simplification is very important. We really need to provide that acceleration. So that acceleration, like taking off, all of that can happen. So once you have done that, you have the larger community. And again, going back to the oil well example, one of the things all these Northern European or Norwegian companies are doing, they have a lot of oil, by the way, they're so progressive, they are opening up their data. You can actually, and it's incredible actually that this is happening in this kind of brick and mortar companies. You would think only the web companies, and even the web companies probably don't open up their APIs in some place. They are opening up their operational data as APIs for others to develop, right? So if you are a machine learning guy, you are a data scientist, but you know nothing of the oil industry, or you don't have access to that, you still, these oil companies are giving you the data to build algorithms on top of it. So we are going to enable a lot of innovation that way. And of course, quality, data lineage, how did this data element come in? All of those are very important, and again, these kind of data abstractions help us to do that. So a data, where does the data reside? I don't know how I'm doing for time. Okay, good, thanks. So where does the data reside? In an industrial IoT pipeline, it of course, data is on the wire. So, data is going from your edge here, from your proximity network to your edge gateway, and then it's going to your cloud. So it's on the wire. And what we've also found is, in IoT, when you take it to the real world, your customers may not have access to the actual sensors, or they are probably buying data from somewhere else. Right? A lot of people buy data, or they are getting it from another department or another part of the organization. So a lot of data is actually in files, and so we need to work with lots of files, and therefore these data lakes, they are very important. Data, of course, lies in these data historians. So all these people have their OSI pies and their G historians, and all that level 1 automation systems. So all those OT systems, the data lies in these OT systems, right? And of course, when you pick the data in your machine learning and environment, it's there in the memory. So, and of course, cloud. People are ingesting. Most of our customers have already built in this kind of data ingestion capabilities. They are picking data. They have an Azure or an AWS and a cloud. They have blob stores. So data is landing up in all those places, right? One of the important aspects is data integration. I really mentioned it earlier briefly, but again, imagine you have an oil well equipment, but when you want to debug that, you need all the time histories, you need all related assets, you need drawings of that, you need service records, you need documents associated with it. So this is a very, very basic requirement, and this is where the benefits of IoT is going to come, when we provide a global view of that data. But the challenge is, it's really these are all in disparate systems. It's very difficult to break these silos, and most importantly, give a context and meaning to it. So systems need to exchange metadata, right? Unfortunately, most systems in industrial IoT, there's no common agreement on the metadata, and there's no common way of exchanging that metadata. Some efforts are being made. There's an organization called ODPI, Open Metadata. I think some of you might know about it. I'm forgetting the full form of ODPI. So they have come out with a way of exchanging metadata. So all these things that I mentioned earlier slide, all the cloud databases and file servers and data lakes and historians, if they have a common way of exchanging metadata. So ODPI has come out with this kind of a bus. Think of it as a metadata exchange bus, where you exchange metadata between these different systems. And when you can have, and they've also come out with that base ontology for describing this metadata. So so that you understand what that metadata means. So metadata is critical. Metadata allows us to do the linkages and integrations, and this is where I think a lot of energy and focus should go into this space, and I think it's important for companies and startups to focus on this area. Okay, and of course another aspect is machine learning. We all know that's where everyone is headed towards. We need to create machine learning models, but unfortunately 80-90% of a machine learning project is actually in data engineering, and we are getting it's getting hampered because there's either not enough understanding of this, there are not enough skills, and these are daunting projects. I mean, these are big projects where you really need to spend a lot of time. I think 80-90% of our effort and our customers' efforts are going into creating that infrastructure and making it ready for machine learning. And that, of course, includes this entire domain of real-time ingestion of data, processing data in stream, how do you efficiently store and retrieve the data, and of course this entire ETL business transformation and logic and etc. So this is very important again, and that's really fundamental to machine learning, and in industrial IoT again this is really becoming important. So what is the challenges? I'm just mentioning two challenges. This is not an exhaustive list. Of course, it's a huge amount of effort has to go in this so-called ETL pipelines, right? And I think ETL companies are going to do well. Earlier, we used to do it for other kind of applications, IT app, but industrial IoT also ETL is extremely important, and it's effort intensive, right? Another challenge is this entire business of making things work together, and this everyone has a different format, whether it's on the wire, whether it's on the database, on the disk, in your algorithm. Unfortunately, a lot of effort, CPU and other things are spent in just making things work together because the memory formats don't agree, right? There has to be a common way of programs written in different languages, for different databases, for different transport protocols. If all of them could agree on a common way, then we would have avoided all this serialization and deserialization, and that would have enabled reuse, and it would have made our entire, all our systems that much more efficient, right? And one such effort is, again, giants, huge, really brilliant people are working towards that. They are trying to bring up all these things, whether it's machine learning toolkits, whether it's cloud databases, whether it's provider of middleware. They are bringing in this in-memory standard, and one such project is this, Apache Arrow, which is very promising, and they are bringing in this standard. So imagine a message coming from an edge gateway. It goes to a cloud database, and from the cloud database, a Python program works on it, and then it creates another output with a visual. Now imagine there is no format translation needing to be done anywhere in all this pipeline. That would be really great. It would save us time, it would save us bandwidth, it would save us CPU, and it would speed up development. So that's what the aim of projects like Apache Arrow is. Right. The other way around, I think why again we need to machine learning. Data engineering, as we saw, is required for machine learning, but again, machine learning itself can be used for data engineering, and especially at the scale of a oil well, oil or petroleum, that project, if you look at it, creating this metadata, if you want human experts to create that metadata, it's never going to happen. There's simply so many assets and so much domain, and so many different silos information. It would be really hard to have people annotate that data, people create those linkages. So humans have to be augmented by machines in building these kind of context, right? In these kind of metadata extractions. So we need machine learning for metadata generation. We need machine learning for the context building, and we need machine learning for creating these digital threads. because human effort is simply not going to do it. It's simply too much, overwhelming. It will never get done. So we need machine learning to do data engineering, which in turn will help us do machine learning. So it's all tied together. And finally, okay, I'm coming to an end. I think this is what my submission is, that I think it is really important. Data engineering and data is important across the chain of IoT. There is a shortage. We find shortage of people, skills, platforms. There's a lot of work to do, and there's a huge opportunity existing for all of us to focus on data and reap the benefits. And there's a huge potential upside which is waiting to be tapped. We can create that impact as long as we have focus on data and data engineering. So thank you.
Great. Any questions? Or, yeah.
Is that, can you hear?
Yeah.
Okay, great. Okay, absolutely wonderful speech. I mean, this is an area I've been thinking a fair amount about, and because I think the power of abstractions to be able to model, because it's like once you have the right abstraction, the right way to think about things, then you can actually start doing stuff. One of the things I've been thinking about, and others too, is biomimicking. Imagining an abstraction where the sensor network, or it doesn't even need to be the sensor network. It's like any number of things they're parts of the body. It's like your fingers are giving you certain sensory input. Your nose is giving you certain sensory input, and your spinal cord does certain things. I think that's a very powerful kind of analogy for in this kind of area. What are your thoughts?
Biology has been inspiring computer science for quite some time. Entire neural network and even much more. So absolutely, it makes sense. And if you take the human body, I think it's the most complex piece of infrastructure that you can think of. So I think the analogy absolutely holds. I think we are probably dealing with much more simpler things in industrial IoT, but yes, I think it is great. I mean, think of that as
maybe, and not just for IoT, across the board.
Yeah.
Great, thank you.
Arnav, I'm working with TCS. So these are slightly related questions that came to my mind. When you're talking about the thing that human should do, like that metadata creation and sharing, is getting replaced by say AI or AI.
It cannot be 100% replaced, but I think it can mostly be. Yeah.
But then from there, my question that's like what I was thinking, that is the business process also going to be changed to become more IoT centric?
No, business processes can leverage the power of IoT, the power like many years back, Vivek Randive, the creator of TIPCO, wrote a book called The Power of Now, and IoT I think really enables that. I mean, you get to get visibility to what is happening right now, so you can optimize your business process. IoT is an enabler for you, right? IoT, like the network. It's part of your network of sensing infrastructure, and it tells you about your business, what's happening right now, and it gives you a granular view of your business operations. So you have the opportunity to tailor it, to remove inefficiencies. I think the killer use case of IoT or industrial IoT is removing inefficiencies in your system, right? Operational efficiency people want, and you can bring about efficiency in your business process through IoT. So I don't think it's like changing your business process, but yes, you have the opportunity to fine tune it, to remove inefficiencies, simply get better visibility. The other thing is, of course, you get to know about your customers, how your customers use your products, what happens here. So you get an unprecedented level of granular view of your business process actually.
I'm also not business. So I have a couple of questions. one of that is regarding the maturity of industrial IoT across all sets of business. So in that world, let us consider it the world is mature enough. There are a lot of aspects that are coming to play, like data security, data governance, data maintenance, along with other aspects like a lot of OEM aspects, like the battery life of different devices in the connected system, networking, the protocols. So keeping that in mind, in that mature world, do you see individual companies or organizations doing the deployment by themselves, or a boutique environment where everyone or multiple boutique firms specializing in each of these aspects, creating a consortium and competing against each other, or a collaborative universe where everyone is, supplementing each other's capabilities?
Yeah.
And
No, absolutely. I think IoT or industrial IoT is where you really do need ecosystems. I mean, you really need a lot of specialists. You need a lot of specialists. It's really complex in that sense. And so I think, of course, there's a role for all kinds of specialist organizations, whether it is, focus. And the 3 tiers, you see, in every tier, you starting from chip vendors, the Qualcomms of the world, to you need the Splunks of the world, and you need the uptake. You need the Azure. You need it's an ecosystem play. You need everyone. Yeah, absolutely. There is. I don't think we or any company can claim that we'll do it all. Impossible. I think we can just contribute our bit to it. And of course the customer is most important. In this journey. Yes.
yeah, also just because it is relevant to our line of work. So how do you see the IT service model or operating model evolving to enable this industrial IoT maturity?
IoT service model.
Yes, IT service model.
IT service model.
Yeah. So will it become more?
I think that's what I was trying to prove here. Get people who are good at processing data. I think you will need such people, and there is a shortage of such people. So if you are giving services, or if you say you are a specialist company which knows data well, knows data management, metadata, context building, you will be in demand. So try to build solutions or competencies or assets in the data area. That's what the whole point of this talk was. So I think if we are not able to provide like a typical Indian IT company that provides outsourced people, you have to generate skills in this area. That's what I'm saying. Thanks.
Thank you so much.